Okay, I had a great question sent to me from one of the students up here from, I think it's a homework problem. So I was going to go through that, and I also just wanted to make sure we talked a little about linear growth versus exponential, so we categorized them differently in our brain, so we knew the difference and knew when to use each different formula. So this problem that she had this last part wrong on says the number of cars sold weekly by a new automobile dealership grows according to the linear growth model. So right now I just can talk about linear growth for a minute. Linear growth grows in a straight line. It grows the same amount for every, so usually we have time on our x-axis and we have the amount of growth on our y-axis. So the time line is our x, and the amount that it grows is the same amount every time for every maybe 1 unit of time that it goes over. So it ends up being a straight line of growth. Exponential is totally different. When you look at it on a graph, it starts kind of slowly and then escalates really quickly, and it's not a straight line. And so we have to use different formulas for each, so we really want to categorize them in our minds. Also, within linear growth, there's two ways we could write the formula: recursive and explicit. So we need to know the difference between each one and how we use each one differently. So this one asks us to do both. So anyway, this is the linear growth model. The first week, the dealership sold 7 cars, and so it told us P sub 0. P sub 0 is always just saying our initial amount. And it's just a convenient way to label our variables, because then we could say P sub 1, well, that's 1 week later. P sub 2 could be 2 weeks later. It says the second week, the dealership sold cars, P sub 1 equals 11. So you see that actually, as we look for the first week, we call it P sub 0. And for whatever reason in this model that they've given us, it says the second week is P sub 1. So the first week, instead of being P sub 1, they're calling it the initial amount P sub 0. The second week being P sub 1. So if you notice really quickly, the second week, usually we would think of that as a number 2. Well, it's P sub 1. So sometimes this happens, and if you notice right here, it says write the recursive formula for the number of cars sold, P sub n, in the n plus 1th week. And they say that n plus 1th week there because those numbers aren't lining up. Like you can see here, the second week, it has a 1 subscript. The first week has a 0 subscript. So if we're looking for the n plus 1th week, in a second here when we get down to the 6th week, like it says here, we have to make sure it lines up correctly with which n we're using. So the recursive formula for linear growth always starts with an initial amount. You have to know the initial, because what recursive does is it builds off of the initial, and you keep going up and up and up from the one before it. And P sub n minus 1 simply just means the term before the one you are at. So if we're trying to find P sub n minus 1 is just the value of the day before, or in this case, the week before. And then the d is the common difference that we're adding each week. So it looks like we are adding, the first week the dealership sold 7, the second week they sold 11, so we're adding 4. And so that's the number that the d ends up being that we substitute into the formula, and so that was correct. Then it says write the explicit formula. Recursive formulas are nice for different reasons, and it's kind of like a ladder. If you looked at my PowerPoint that I sent out, but it's kind of like a ladder where you have to get to the second rung on the ladder, you have to step on the first. And to get to the third rung on the ladder, you have to step on the second. And recursive is like that, where if we wanted to find out, the 6th week, we would have to know the 5th week. But to know the 5th week, we would have to know the 4th week, because the way the formula shows us is we just add the common difference to whatever was the step on the ladder before. So it's a nice, clean formula, but it doesn't really help us when we're predicting long time in the future, because we don't want to have to work every single rung of the ladder just to get to the next one. So explicit is nice because it just gives us an explicit formula where we can work out really far down the line, 10 weeks in the future, 20 weeks in the future, without having to know the 19th or the 18th. So write the explicit formula. So again, these formulas will be given to you, but they won't be labeled. You'll just have to know that this is the linear growth recursive, this is the linear growth explicit. So we start with the initial P sub 0, which she did correctly here. She wrote 7 was the initial, so we input, here's our formula, P sub n. We say, okay, we want the initial P sub 0, so I fill that in with my 7, plus d. Is my common difference, so that's 4, and we leave the n and n. So we just kind of fill that in, so that one was correct. But here's where she had a question that said, if this trend continues, how many cars will be sold in the 6th week? we have to be very careful about this because sometimes we just assume, oh, 6 means that n is 6. But remember up here we realized this is for the n plus 1th week. So if we're looking for the 6th week, what are we going to plug in for n? Well, you could write it out. P sub 0 is the 1st week. P sub 1 is the 2nd week. P sub 2 is the 3rd week. P sub 3 is the 4th week. But you start to see a pattern. It's always one less than the week number you're finding. So if the 6th week is going to be P sub 5. So we're actually trying to find P sub 5 here, not P sub 6. Just because, for whatever reason, we started with P sub 0 as our first week. Instead of P sub 1 as our first week. It's just a labeling issue, which we have to make sure we account for when we're plugging in our n. So the 6th week is actually a 5. So we would do, to find P sub 5, the 6th week, we'd do 7 plus 4 times 5. So 27 for that answer. So be careful about that, making sure you're lining up with whatever you labeled as the first week. You know, we could have avoided that problem if they would have labeled it P sub 1 as first week. P sub 2 is 2nd week. P sub 3 is 3rd week. Anyway, then P sub 6 would be, n would be 6. So always look for that. Okay, and then I just want to give an example of an exponential growth problem. This is from your written assignment. So I thought I'd talk about it really quick because I had another student send me a question on how to set this up. So consider an apple orchard. He hires his daughter, Mr. Smith hires his daughter to pick apples and offers 2 payment options. Either she can earn $1.50 per bushel of apples picked. So you can kind of see that that's linear growth because every bushel that she picks, she earns $1.50. Another bushel, $1.50. Another bushel, $1.50. So this would grow linearly. Or we could do this one which grows exponentially, 1 cent to 3 cents for 2 bushels, and to 9 cents for 3 bushels, and so on, tripling for each additional bushel picked. We got to figure out what this means. I can tell it's exponential, tripling. So here's the formulas for exponential growth. In the formula, both of them have an r in them and a 1 plus r. R is the growth rate. If you're ever involving a percentage, that's going to be your r. Percentage. Sorry, very sloppy. 1 plus r is your common ratio. That's the amount that you're multiplying by each time to get to the next one. So I kind of want to look at this numbers. We have 3 going to 9, going to 27. We're multiplying by 3 each time, right? 3 each time. So our 1 plus our r, our common ratio, the number that we multiply by each time to get to the next term is 3. What does that make our r? If 1 plus r is 3, if we subtract 1 on both sides, r is 2. So the growth rate is 2. I said that's a percentage, so 2 is like a 200%, because if I change the number 2 to a percentage, remember I times that number by 100, I would get a 200% growth. And I just wanted to show you that that is what's happening here. This is a 200% growth. When you go from 3 to 9 is 200% growth rate. Because you take the original 3, you take 2 times 3, which is 6, and add it on top of it. So 2 times 3, it's really messy down here. 2 times 3 is 6. That's the 200% increase, and then we add it on top of the original 3, making it a 9. And again, 2 times 9 is 18. There's that 2 again, the 200% times the original 9 added on top of the 9. We get 27. So it's a 200% growth rate. The r is 2, but our common ratio is tripling, so it's 3. So if we were going to model this, now I could model it recursively or explicitly, but I probably want to model it explicitly just in case I want to make a prediction way down the line like it asks us to later. I could start by saying P sub n equals 1 plus r. I said 1 plus r is 3, so I'll just replace that with a 3 to the n power times P sub 0, our initial amount. And our initial amount in this case was 1 cent. But here's where we want to make sure that this is going to work out. Whenever you write yourself a formula, go ahead and check it with, and I put x's and y's here. I was going to do x's, y's. We could always do p sub n's and n's. P sub n would be like the money that we end up making, and n would be like the number of bushels. But let's make sure that this works out, because it says for 1 bushel I should make 1 cent. Well, if I put a 1 into the n spot here, what do I get? Do I get 1 cent? Because if not, I'm going to have to adjust this somehow, a little bit like we did where it was set up this way. So if I put a 1, because P, or the initial amount, if we want to start at 0, P sub 0 actually, just because that's how we usually do P sub 0, we could say, let's put a 0 in the end spot then. 3 to the 0 power times 0.01. Anything to 0 power is 1, so yep, this ends up being 1 cent. Then P sub 1 would be 3 to the 1 power times 0.01. And you just check your formula and look what we get. We get 0.03 cents. P sub 2 is 3 to the 2 power. So as long as we start with our initial as being P sub 0, but remember, P sub 0, this means day 1. And so P sub 2 would, well, I mean, I guess we're not in days, are we? This means 1 bushel. I should erase here. Okay, so we were not working in days, we were working bushels, so bushel 1, bushel 2, bushel. So you can see it's a little bit off again, just kind of like this one was. Bushel 1 was P sub 0, bushel 2 was P sub 1. So when you're finding bushel 3 was P sub 2, so for instance, if we're going to find bushel 12, we would need to put in an 11 into our function. So anyway, those are just 2 examples of when we end up having the number that we're at being different than the n that's in the formula, just because we start with P sub 0 being our first bushel. I hope that helps. Keep sending me questions because it helps me to know what I should help you with. So have a great day.